Today we're covering an engine component with a huge responsibility. If this part fails, major engine damage can occur. It's one of the most critical timing components in a diesel engine, and it's the camshaft. Before we get too technical, here's a simple way to picture it. Think of the camshaft like a conductor in an orchestra. The pistons, the valves, and the injectors are all musicians. They're powerful on their own, but without a conductor, everything happens at the wrong time. While the camshaft doesn't make the power itself, it controls the timing, making sure every part moves exactly when it should. The camshaft controls when air enters the engine, when exhaust leaves, and on some diesel engines when fuel is even injected. By the end of this video, you'll understand what a camshaft does, how it's built, how it stays timed to the crankshaft, common failures, modern dual overhead cam designs, and why valve lash adjustment is so important. The camshaft is often called the mechanical brain of the engine. Its job is to control timing and movement of the valves inside the cylinder. In diesel engines, the camshaft is responsible for opening intake valves to let fresh air in, opening exhaust valves to let burn gases out, and on older systems, operating fuel injectors. The camshaft ensures all of this happens at exact moments during the four-stroke cycle. These four strokes, again, are intake, compression, power, and exhaust. If the camshaft timing or movement is incorrect, the engine may lose power, run rough, produce excess emissions, or fail completely. So think about this. If the intake valve opens too late, what happens to airflow? Less air means less power. If the exhaust valves open too early, what happens to cylinder pressure? You lose usable energy. Camshafts are built extremely strong because they operate under high loads for long periods of time. They are typically made from cast or forged alloy steel. They're also heat treated for strength and wear resistance. The main parts of a camshaft include lobes. These are the raised sections that push on the valve train. Journals, the smooth areas that ride in cam bearings. Gear or sprocket, this connects the camshaft to the crankshaft. And injector lobes. These are only found on engines with mechanical injectors. Each cam lobe is precisely ground. Even a tiny change in lobe shape affects airflow, combustion, and engine efficiency. In a four-stroke engine, which most heavy-duty diesels will be, the crankshaft rotates twice for every one rotation of the camshaft. This is called the 2-to-1 ratio. Now, why doesn't the camshaft rotate at the same speed as the crankshaft? Well, that's because the valves only need to open once every two crankshaft rotations. Intake and compression strokes make up one crankshaft rotation, power and exhaust strokes make up the other rotation. The camshaft is driven typically by timing gears, which are very common in the heavy-duty engines, possibly with timing chains, and occasionally some belts, but typically you don't see too many of that on the heavy-duty stuff. And this timing ensures that the intake valves open at the right time, exhaust valves close exactly when they're supposed to, and injectors fire at the correct crankshaft angle if mechanically actuated. If timing is off by even a few degrees, starting can become difficult, power can drop, fuel efficiency can suffer. In severe cases, valves can even contact the pistons. Camshaft is designed around three key characteristics. Lift, which is how far the valve opens. More lift allows more airflow, but also increases some stress. Number two is duration, how long the valve stays open. Diesels usually use a shorter duration than gas engines to prioritize torque and efficiency. And overlap, the brief period when intake and exhaust valves are open at the same time. Diesel engines typically use very little overlap to reduce emissions and maintain clean airflow. Camshaft profiles are engineered to balance torque, fuel economy, emissions, and durability. In most heavy-duty diesels, the camshaft doesn't touch the valves directly. The path usually looks like this. The cam lobe rotates, a lobe pushes against a roller follower, also often called a tappet. The follower, or tappet, moves a push rod. The push rod moves a rocker arm. The rocker arm opens the valve in the cylinder head. And valve springs then close the valve and keep everything in contact with the cam. This entire system relies on proper adjustment and proper lubrication, as camshafts work in difficult conditions and they can develop problems. Camshaft issues usually develop slowly but can cause major problems if ignored. Common failures may include worn or pitted lobes from poor lubrication, bearing damage from oil pressure loss, or timing gear wear or breakage. Incorrect valve lash can lead to accelerated wear. These problems may show symptoms that include excessive valve train noise, low power, hard starts, poor fuel economy, or engine misfires. When inspecting a camshaft, mechanics may visually inspect the lobes for uneven wear, measure cam lift using a dial indicator, inspect the followers and rollers, and check cam bearings for scoring or play, verify the timing marks are in the correct place, adjust the valves, and injector lash. Now, so far we've mostly been talking about single camshafts, which are located in the block and transfer that motion from the camshaft lobes through the cam followers or tappets, through push rods, and through rocker arms to open the valves. However, some modern diesel engines are increasingly using dual overhead camshaft or DOHC designs. One specifically operates the intake valves, and another one operates just the exhaust valves. Advantages of a dual overhead cam system include more precise valve timing, reduced valve train mass, improved airflow and combustion, and an easier use of 4-valve cylinder heads, and along with better emissions control. Some disadvantages of a dual overhead cam setup may include more complex timing systems, more components to service, and higher precision required during installation. We touched on this a little bit earlier, but one of the most important camshaft-related adjustments is valve lash. Valve lash is the small clearance between valve train components when the valve is fully closed. This clearance is intentional and absolutely necessary for a few reasons. Number one being thermal expansion. As engine parts heat up, they expand. This lash prevents the valves from being held open. Number two, proper valve sealing. Correct lash ensures full valve closure, which maintains compression and prevents burnt valves. Number three, accurate camshaft timing. Incorrect lash changes when valves effectively open and close. So what's the big deal if the lash is off a little? Well, if the lash is too tight, results can be low compression, burnt valves, hard starting, or misfires. All things we don't want. Valve lash directly affects engine performance and camshaft life. That's why diesels will have PM preventative maintenance schedules for adjusting the valves to make sure they stay within spec. The camshaft controls breathing, timing, and power in a diesel engine, and valve lash ensures it all happens correctly. Mastering these fundamentals is a key step toward becoming a skilled heavy-duty mechanic. And if you're looking for more information on those 4 strokes we mentioned earlier in the video, I've got a video right here you should check out to learn a little bit more about that.